All right, summarizing limits a little bit more with you. There's Coco Bananas. There she is. Oh, such a good weasel. Okay, so when somebody gives you a limit problem, you go for it. You just substitute in, and you're happy if it works. So a real simple example right here. You pop in the 2, and you don't get anything illegal. Everything works just fine. It just works just fine. So you're done. And what it means is, if you were to graph this function, that when the x-coordinate is 2, the y-coordinate is 5. Just like usual, nothing strange. But what it actually means is, as you approach the x-coordinate of 2, you're also approaching the y-coordinate of 5. Which is what it does. It's just this thing here would be a curve, and you would approach the point 2 comma 5. As x approaches 2, you'd approach y equals 5. Now, this is the case that's going to get all the press. You tried to substitute in, you got 0 over 0, which means you have more work to do. You're not done yet. Can you find the cause of that downstairs 0? And can you cancel it out? Can you cancel it out? I don't know. So you give it a try. You give it a try, right? All right, so you look at this thing here. You put in x equals 1. You get 1 minus 1, that's 0. 1 plus 1 minus 2, that's 0. But x squared plus x minus 2 factors. And of course, there's a factor of x minus 1 because you have a 0. So big hint to you guys. You see that x minus 1, you have a 0 down here. There's probably an x minus 1 down there to get. So you factor it. You got an x minus 1. You need to have something that gives you that negative 2. Well, it's negative 1 times 2. And then if you notice, negative x plus 2x gives me the plus 1x. So you got it right. Yay! Anyway, now canceling out those x minus 1s only leaves a 1 because you canceled by division. You canceled by division, so there's a 1. And then there's a x plus 2 down there. This is the limit as x approaches 1, remember? So I have a 1 over 1 plus 2, that's 1/3. Now I graphed it on my calculator. Check it out. A wonderful thing happened. I hope you can see this. Let me get it nice and clear for you. This is the function. Come on, baby. Make it clear. Do you see that gap? Do you see it? Do you see it? That's the hollow point. I got a hollow point on screen for you guys because I love you. That's the place. That's the place where this curve doesn't exist at x equals 1, y equals 1/3. There's a gap. But what's the limiting value? As x approaches 1, y is approaching 1/3. Doesn't matter if there's no point at that point. We're talking about what happens when you get close to the point, 1 comma 1/3. And then here's just as good as the first one, really. If you got a downstairs 0 that you cannot get rid of, that's a does not exist limit, and you're done. So that's basically limits, you guys.